Check Maughan from Trinity College Dublin.
Hi folks, so the pages of a book act very differently to the book itself, allowing you to do things like fold it, burn it and get paper cuts off it much easier than you could with the entire book. If you apply the same principle to the graphite that you find in pencil leads, you get a material called graphene, consisting of thin layers of carbon atoms, which can conduct electricity even when combined with plastic. So my work focuses on taking this new nanomaterial and using it to fabricate advanced neural interfacing devices. With a flexible backing between microneedles based on this graphene material, we can develop devices that allow you to both stimulate and record signals in the brain. So we're currently assessing these electrodes for their potential for bidirectional stimulation by seeing whether they can be used to stimulate neuronal growth and whether we can record electrical signals from neurons using microneedles of this material. So this work could lead to advances in long-term, high-resolution neural interfacing, which is a technology with profound implications for neuroregenerative and augmentative technologies.